Clan here for Clan Maths. Today we're going to go through higher maths in the circle. So we're going to look at the equation of a circle. We're going to test a point and see if it's on a circle or not on a circle. General equation of a circle, intersection of circles, equation of tangents and intersection of lines and circles. And of this will be full teaching plus every single past paper. Let's go. So what is the equation of a circle? Well, I've drawn a circle on my coordinate grid here, and you should be able to see that we have got r as the radius because it goes from middle to the outside, and then the centre is 0, 0 for this circle, but it doesn't have to be 0, 0. And I've just defined a point as 3, 4 for this circle, and we should be able to see that using Pythagoras, that's 3 and that's 4, so the radius is 5. So we could say that 3 squared plus 4 squared equals 5 squared for this circle, right? Now that gives us the radius. Therefore, if I just call the direction along the way x and the direction up the way y, x squared plus y squared equals r squared is the equation of a circle as long as the centre is 0, 0. So the centre has to be for this 0, 0. And we're going to start looking at circles with the centre 0, 0 and then move the centre along. So example 1 says, state the equation of a circle with centre 0, 0 and radius 5. Well, that's nice and easy. We know that x squared plus y squared equals r squared for a centre of 0, 0. I'll just write c as 0, 0. So we've got x squared plus y squared equals 5 squared, or if we prefer, x squared plus y squared equals 25 would also be appropriate. Example 2, state the centre and radius of the circle with equation x squared plus y squared equals 121. Okay, so we know the centre is 0, 0, and that's because it's x squared plus y squared equals r squared. And then we need to find the radius. Well, since we know it's x squared plus y squared equals r squared equals 121. So the radius is simply the square root of 121. And we could work that out. It's 11. So the radius is 11. Whatever the units are, most of the time we won't be told centimetres, metres, or anything like that. Example 3, state the equation of a circle with centre 0, 0 that passes through the point minus 5, 12. Well, we know that if it's got a centre of 0, 0, x squared plus y squared equals r squared. But we have a point. The point is minus 5 and 12. Well, that's an x and that's a y. So we can just sub that into our equation. So we get minus 5 squared plus 12 squared equals r squared. That's 25 plus 144 equals r squared. So that's 169. And therefore r is the square root of 169. So r equals the square root of 169, which is 13. So we've found our r, so now we can just write our equation. I'll just put it in this big box here. X squared plus y squared equals 13 squared, or x squared plus y squared equals 169. And we're done there. Okay, let's dive further into the equation of a circle. We've already looked at the equation of a circle with centre 0, 0, but what about just a random point being the centre? So I've drawn a circle with a random point to centre, so that's AB, and the point on the circle is called XY. So I suppose what we need to work out is, what's the distance between here and here, and what's the distance between here and here? Well, you should be able to see, I'll zoom this in, that the distance between here and here is just x minus a, the difference in the x parts. So I could write x minus a for down here, and the distance going vertically is just y minus b. So I could write y minus b, and then by Pythagoras, the equation of this circle is simply x minus a squared plus y minus b squared equals r squared. And therefore, we've now got the equation of a circle where the centre is not 0, 0. So for any centre, the equation of a circle is x minus a squared plus y minus b squared equals r squared. Okay, let's do a little work on this. So the equation of a circle with centre AB and radius r is x minus a squared plus y minus b squared equals r squared. And I've got a little table here, and it says, here's the equation of a circle. We have to write down the centre and write down the radius. So to get the centre, x minus 5, y minus 1. So a and b is here, so it's just 5, 1. And the radius is 8 squared. R squared is 8 squared, so r is just 8. Let's look at the other one down below. x plus 5, but it's x minus a, so that first number must be minus 5 for the centre, because minus is a plus, and x plus 1, so it must be minus 1, because minus 1 is plus 1, and r squared is 100, so the square root of 100 is 10. So we get minus 5, minus 1 for the centre, and 10 for our radius. And the last one, x minus 2 squared, y plus 1 squared. So I've got x minus 2, it's already in the right form, so it's just 2. Y plus 1, well, I want it to be minus 1 then. And the radius, we've got r squared is 65, so we could write the radius as the square root of 65. Square root of 65 is a third, and we leave our answers often as in simplified thirds, or if it's a calculator, just work that out. Okay, let's work backwards. We're going to give you the centre and the radius, and you have to work out the equation of the circle. Have a look, see if you can do it. Okay, the first one, centre's 4, 9, so I just write x minus 4 squared plus y minus 9 squared, and that equals the radius squared, 7 sevens, 49. Okay, the next one, the centre's minus 2, 9, so I've got x plus 2 squared, flip the sign, plus y minus 9 squared, equals root 3 times root 3 is just 3. And the last one, minus 2 minus 6, so x plus 2 squared plus y plus 6 squared, and the radius is 2 root 5. So let's do a little bit of work on that. We need to do 2 root 5 squared. So that's 2 times 2 is 4. Root 5 times root 5 is just 5. That gives me 20. So my radius squared is 20. And we're done there. Okay, let's go to an example. The circle with the centre 1, 4 passes through the point 5, 6. Find the equation of this circle. So we know this general equation of the circle is x minus a squared plus y minus b squared equals r squared, where a and b is the centre. So that's the thing you're keeping in check there. You can check the start exam paper for that, it gives you it. So using the centre, that's our a, that's our b there. So we've got x minus 1 squared plus y minus 4 squared equals r squared. But we're not told the radius. However, we are given a point on the circle. So that is our x and that is our y because it's on the circle. So we just sub that in to get 5 minus 1 squared plus 6 minus 4 squared equals r squared. 5 minus 1 is 4 squared. 6 minus 4 is 2 squared equals r squared. 4 fours is 16. 2 twos is 4. That means r squared equals 20. There was no reason to square root that because we want the equation of a circle, which we need r squared for, so we can just write down the answer now. X minus 1 squared plus y minus 4 squared equals 20, and we're done there. Okay, the circle, we're going to look at testing a point. So by testing a point, I mean we're going to check if a point is either on the circle, outside the circle, or inside the circle, okay? Now, if you were to think of a point on a circle, let me just draw a picture here, ignore the example for now. There's a circle there, and there's our centre, say, right? Well, if we had some random point, we'll do that in red. The point could be either there, or it could be on the circle, or it could be way outside the circle, right? Now, if it was inside the circle, obviously the distance between here and here is smaller than the radius, okay? So if it's inside the circle, the distance between the centre and the point is smaller than the radius. Obviously, if I look at the point on the circle, well, there it is there, the radius and that point is exactly the same. So if a point is on the circle, that means the distance between the centre and the point is exactly the same as the radius. But the last thing that could happen is we could have a point way outside this circle here, and that distance here clearly is much bigger than the radius. So if the distance between the centre and the point is bigger than the radius, it means the point is not in the circle, it's outside the circle. Let's see that in an example. The circle has equation x minus 2 squared plus y plus 5 squared equals 29. Determine where the points 2, 1, 7 minus 3 and 2 minus 4 lie in relation to the circle. So all we need to do is check by subbing it in and see what you get. If you get an answer the same as 29, it's on the circle. If it's smaller, it's inside, and if it's bigger, it's outside. So let's look at 2, 1. Subbing that in, we get 2 minus 2 squared plus 1 plus 5 squared. They're not equal to 29. We're going to see what it equals. 2 minus 2 is 0 squared. 1 plus 5 is 6 squared, which equals 36. And then we just make a little statement. 36 is bigger than 29, therefore 2, 1 lies outside the circle. We don't actually have to square root the numbers, because if we square root 36 and square root 29, clearly square root 36 is bigger than the square root of 29. Okay, let's check the next point. 7 minus 3. So that gives me 7 minus 2 squared plus minus 3 plus 5 squared. 7 minus 2 is 5. Minus 3 plus 5 is 2. 5 5s is 29. 5 5s is 25, 2 2s is 4, which gives me 29 in total. And we can just say 29 equals 29. Therefore, 7 minus 3 lies on the circle. And the last one we wanted to check was 2 minus 4. So looking at 2 minus 4, our equation is x minus 2. So 2 minus 2 squared plus y plus 5 minus 4 plus 5 squared. Well, that gives me 0 squared plus 1 squared, which equals 1. 1 is clearly less than 29, and therefore 2 minus 4 lies within the circle. And we're done there. We're going to look at what we call the general equation of a circle. That is when, instead of taking x minus a squared plus y minus b squared equals r squared, we expand the brackets, essentially. Let's do this as an example. Let's say I've got the circle x plus 2 squared plus y minus 3 squared equals 25. Well, I can expand the first bracket. That gives me x squared plus 2 times x is 2x, so that's doubled to 4x, plus 2 2s is 4. And then we can do the same with the second bracket. That's y squared. 3 times 2 is 6, so it's minus 6y, and then 3 3s is 9, and that equals 25. And then we can just collect the terms in a nice way, so the x squares and the x's and the y's, and then the numbers all together. So it goes squared, and then x, just linear, and then the constants at the end. So if I do that, just by rearranging it, I've got x squared plus y squared first. Then I've got 4x minus 6y, and then I've got 4 and 9, and that makes 25. Now always we just make the right hand side 0, so you've got x squared plus y squared plus 4x minus 6y. 4 plus 9 is 13. If I take away 25, I get minus 12 equals 0. So the general equation of a circle for this particular one would be that equation. And I'll show you what it is in general, but let's look at some of the patterns in this. You should be able to see because of expansion. If you go back to the equation up here, you've got x squared plus y squared, and then you've got 2 becomes double, and 3 becomes double, and then you've got some number on the end. But how did we get that number? Well, we took each of these numbers squared, 2 squared and 3 squared, and then took away this number here. So we can actually do that with the algebra. So let's just look at in general. A's and B's get changed to G's and F's for this, just for the sake of it. But there it is in expanded form. I'll prove that is the equation of a circle by refactorising it. If I take the two terms there, x squared and 2gx, I can think of that as, well, completing the square. So half the middle term, x plus g squared. But then, since I'm completing the square, I need to take away g squared. I can do the same for the y part, so I get y plus f squared, but then I need to take away f squared because I'm completing the square, and then I've got plus c equals 0. X plus g squared plus y plus f squared. Moving everything to the right, we have got minus g squared becomes g squared, minus f squared becomes f squared, and that's minus c. Well, g, f, and c are just numbers, so that could be like r squared. So I've got x minus a squared plus y minus b squared equals r squared. Essentially here, it says plus instead of minus, but that doesn't make a difference because a number can be negative anyway. So we now know that the centre of this, if it's written in this form, is simply minus g minus f. And the radius squared is equal to g squared plus f squared minus c. Or the radius is equal to the square root of g squared plus f squared minus c. Now, at higher maths, you do not have to memorize these formulas. They're given to you at the start of exam paper. So it will tell you, if it's written in this form, a general equation of a circle, that's the centre and that's the radius. You just use that. And obviously, for it to be a circle, this has to be greater than 0 because you can't square root a negative number. So we could say that that has to be greater than 0. Obviously, if it was equal to 0, then again, you wouldn't have a circle, you just have a point, wouldn't you? Okay, general equation of a circle, example 1. Find the radius and centre of a circle with this equation. So we check the start of the exam paper, and the start of the exam paper says x squared plus y squared plus 2gx plus 2fy plus c equals 0. And it also tells us at the start of the exam paper that the centre is minus g minus f. And the radius is equal to the square root of g squared plus f squared minus c. So then we can just use that. Comparing the bit here, we've got 4x is 2gx, so we can just say that 4 is equal to 2g, so g is equal to 4 divided by 2 is 2. And we've got minus 8 is equal to 2f, so that means that f is equal to minus 8 divided by 2 is minus 4. So we've got our g and our f. So our centre is equal to minus g, that's minus 2, minus f, that's 4. And our radius is equal to the square root of 2 squared minus 2 squared plus 4 squared. And then c, well, c, remember, is the n number, which is 7. So take away 7. So we work that out. That's the square root of 4 plus 16 minus 7. That is root 13. And we're done there. Example 2 for a general equation of a circle. Explain why x squared plus y squared plus 4x minus 8y plus 29 equals 0 is not the equation of a circle. So start of the exam paper tells us that x squared plus y squared plus 2gx plus 2fx, fy, minus c plus c equals 0. Okay, so we know if it was a circle, 2g would equal a number in front of x, which is 4, so g would equal 2. And if it was a circle, 2f would equal minus 8, which means that f is minus 4. So our centre would be minus g minus f, which is 1 minus 2. That's not an issue. But what about the radius? Well, looking at the radius, remember, from the start of the exam paper is the square root of g squared plus f squared minus c. Well, that would give me the square root of 2 squared plus minus 4 squared, and c is 29, so take away 29. That's the square root of 2 2's is 4, 4 4's is 16, so that's 20 minus 29, which is the square root of minus 9. Well, you can't have the square root of minus 9, so it's not a circle because minus 9 is less than 0, so not a circle. I want a section of circles. So imagine we've got 2 circles and we're looking at one of them with a radius of R1, say, and one of them with a radius of R2. So we can draw these 2 circles, and we'll imagine those radiuses are different, of course, with the first radius R1 being bigger than the second radius R2. And we're looking at the distance between the centres of the circle. Well, a number of things that can happen, okay? Whether the circles touch or don't touch, whether they touch once or twice, whether they touch internally or externally. So imagine the circles don't touch to start with, looking at this side here. If they didn't touch, and the standard picture being that they're far apart from each other, then clearly this distance is much bigger than the 2 radiuses combined or added together. So we could say the distance is bigger than the 2 radiuses added together. But there's another way we can't touch. If they don't touch, but they are inside each other, you've got the small one drawn inside the big one, like so, then you can see that the distance between the centres is very small. In other words, the distance between the centres is less than the radiuses taken away from each other, the big one minus the small one. So now if we only touch once, we could either be drawn like this next to each other, and then you should be able to see that this distance here is r, 1, and this distance here is r2. So r2 plus r1 equals the distance. If the distance equals the radiuses added together, then they touch at one point. But we could touch inside the circle, and then if that happens, if we take away the radiuses, the big one minus the small one, that equals exactly the distance drawn. Now you can see that because imagine I drew this big one here, and then that one goes to there. I'm just taking away that distance to get this bit in the middle. And then, of course, the circles could meet at 2 points. So we could draw them like this where they intersect. So we've got the big distance here, and we've got this distance here. You should be able to see that the distance between the centres is in between the difference between the radiuses or the radiuses added together. So if you add the radiuses together and take away the radiuses together, if that distance is in between there, it means the circles are touching twice. Example 1, for intersection of circles, circle P has -4, -1 centre with radius 2, and circle Q has x squared plus y squared minus 2x plus 6y plus 1 equals 0. Show that they do not touch. So I just need to check the distance between the centres. So the centre of P, centre, is -4, -1, and we know the radius is equal to 2. And the centre of Q, well, remember that's minus G minus F. So G is, we've got -2, so that becomes -1, which becomes 1. And then we've got 6. 6 divided by 2 is 3, so that's -3. And the radius is equal to the square root of 1 squared plus -3 squared minus 1. 1 squared is 1, 3 threes is 9, 9 plus 1 is 10, minus 1 is 9, that's root 9, which is equal to 3. So we know our two radiuses are 2 and 3. And check the distance between the centres. So the distance between the centres, using the distance formula, or basically Pythagoras, remember, you do x2 minus x1 squared, so -4 minus 1 squared, plus y2 minus y1 squared, -1 minus 3 squared. That equals the square root of -5 squared, plus -1 plus 3 is +2 squared. So we've got an answer of the square root of 25 plus 4 is 29. So we know our distance between the centres is 29. So if we add the radiuses together, let's call that R1 and R2. R1 plus R2 is equal to 5. So what is the square root of 29? We should probably work that out in case you don't know, but 5 5 is 25, 6 6 is 36, but exactly it is 5.38 or 5.4. So the distance between the centres is bigger than the radiuses added together. So since root 29 is bigger than 5, the circles don't touch. And that's it. Example 2 for intersection of circles. Circle R has this equation and circle S has that equation. Show that they touch externally. Find the centres and the radiuses. So the centre of R minus G minus F, remember. So 2 divided by 2 is 1. And 4 divided by 2 is 2. And the radius is the square root of 1 squared plus 2 squared minus C. So minus 4, so plus 4. 1 times 1 is 1, 2 twos is 4, that's 5, plus 4 is 9, so that gives you 3, the square root of 9. Now we look at centre S. The centre of S is simply 4 and 6, and the radius is equal to the square root of 4, which is 2. So we've got our two radiuses, we've got our two centres, so let's just check what's the distance between the centres. So the distance, using the distance formula, is equal to the square root of 4 minus 1 squared, plus 6 minus 2 squared. 4 minus 1 is 3 squared. 6 minus 2 is 4 squared. That's 9 plus 16 is 25, which is 5. So the distance between the centres is 5, but if we call that R1 and R2, R1 plus R2 also equals 5. Therefore, the circles touch once externally. should be obvious because the radius is exactly the same distance away as the centres. Example 3, circle A has this equation, circle B has that equation, show that they touch internally. So again, centre of A is 3 minus 3, and the radius is the square root of 64, which is 8. And the centre of B is minus 1. Now, notice this says y squared here, so it's just 0. And the radius is the square root of 9, which is 3. So should I check the distance between the centres? So the distance is equal to 3 minus minus 1 squared plus minus 3 minus 0 squared. That's 4 squared plus minus 3 squared. 4 fours is 16. 3 threes is 9, so that's 25 again, which is equal to 5. Now, clearly, R1 plus R2, we call that 1 and 2, is bigger than 5, but we also need to check what about taking away. So R1 minus R2 is equal to 8 minus 3. Does that go 5? So since R1 minus R2 equals 5, circles touch internally at one point. Equations of tangents to circles. So we know from that 5 that if we have a circle and a tangent to that circle, they meet the radius at right angles. The radius and the tangent meet at right angles. But we now know from straight line that if two lines are at right angles, they're perpendicular. That's the definition. Gradients of those times together to make minus 1. So that means that we can find the gradient of the tangent if we know the gradient of the radius, since the gradient of the radius times the gradient of the tangent are going to equal minus 1. So if we knew the point of contact there, and we knew the centre, we could find the gradient of the radius, and therefore we know the gradient of the tangent. And we've also got a point on this edge of the circle, so we could use y minus b equals mx minus a. So, equation of tangent circle example. The point A, 1, 3 lies in a circle with equation x squared plus y squared plus 6x plus 2y minus 22 equals 0. Find the equation of this tangent at A. So if I draw a little sketch of this, you've kind of got a circle with a point, let's say up here, 1, 3, and that's A. And you've got its centre there. Well, what is its centre? Remember, minus g minus f. So 6 divided by 2 is 3, so that's minus 3. And 2 divided by 2 is 1, so that's minus 1. And then there's our radius there. So our tangent will kind of go like that. So we can find the gradient, let's call that C, the gradient between the centre and A. y2 minus y1 over x2 minus x1. So that's 3 minus minus 1 over 1 minus minus 3. That's 4 over 4, which is 1. Therefore, the gradient of the tangent is equal to minus 1, and since m1 times m2 equals minus 1. So we've got a gradient of minus 1, and the point is 1, 3. So we just write that down. Gradient equals minus 1. The point A is 1, 3. So that's our A and B. Y minus B equals m. X minus A is the equation of the tangent. So y minus 3 is minus x add 1, or y equals minus x add 4 by taking it across, and we're done there. Okay, we previously did intersections of circles, but we can do intersections of lines of circles. So what did we do? One, the tangent, and we can find the equation of the tangent. But obviously, two other things could happen. I could draw a line straight through a circle, and obviously it meets it at 2 points, so 2 intersections. Obviously, we've got the tangent situation, and then obviously, the other situation would be I could draw a line and I could draw a circle, and they wouldn't touch at all. And we can just use substitution by substituting in the line into the circle to work out how many times it touches. Because when you substitute, you'll get an equation, and you can then see how many solutions that equation has. So here's an example. Find the points where the line with equation 3x, y equals 3x, intersects with the circle x squared plus y squared equals 20. So y equals 3x. So I've got x squared plus y is 3x, so 3x all squared equals 20. So we need to solve that equation to see what point they touch it. X squared plus 9x squared equals 20. So 10x squared equals 20. So x squared equals 20 divided by 10 is 2. So x is the square root of 2. But when you square root a number, you get two answers. So plus or minus the square root of 2. And we have to find the points we intersect. So when x equals root 2, y equals, well, 3x, 3 root 2. So our first point is root 2, 3 root 2. And when x is minus root 2, y is 3 times minus root 2, which is minus 3 root 2. So our next point is minus root 2 minus 3 root 2. And we're done there. Okay, example 2 for intersection of lines and circles. Find the points where the line with equation y equals 2x plus 6 and the circle with this equation intersect. So we've got a trickier one to substitute in, but it's okay. We know what y is, so we'll sub it directly in. X squared plus 2x plus 6 plus 2x plus 2y, 2 times 2x plus 6 minus a equals 0. So subbing it in means we're solving simultaneous equations. So we just be very careful expanding our brackets. 2x squared, that's 4x squared. 2 times 6 is 12, so I double that to 24x. 6 6 is 36, plus 2x, plus 2 times 2 is 4x, plus 2 6s is 12, minus 8 equals 0. Collecting our terms in, we've got 5x squares, and then we've got 24, 25, 26, 30x's, and then we've got number part 36 plus 12 is 48 minus 8 is 40. So we've got plus 40 equals 0. So we've got a quadratic to solve. So 5 is a common factor. So I'll take that out. So we get 6x plus 8. And then hopefully we can just use double brackets at this point. If not, quadratic formula. We get x and x. We get 4 and 2. And we get plus and plus. So that means x equals minus 2 or x equals minus 4. And we have to find the point. So I've got our x, so I'll sub it back in to get our y. Is equal to 2x plus 6, remember? So when x is minus 2, y is 2 times minus 2 plus 6. That's minus 4 plus 6, which is 2. So our point is minus 2, 2. And then when x is equal to minus 4, y is equal to 2 times minus 4 plus 6. Well, that's minus 8 add 6, which is minus 2. So again, our point is minus 4. And in a section of lines and circles, example 3, show that the line with this equation is a tangent to the circle with that equation. Okay, so we're just going to sub it in and see how many points we get. So we've got x minus 3y equals 5. Well, that's not very useful. So we'll rearrange that into a better form. Now you can make y the subject or x the subject and sub it in. It's easy to make x the subject in this case. So I'll just say that x is equal to 5 plus 3y and sub it in. So x squared becomes 5 plus 3y all squared plus y squared minus 6 times 5 plus 3y, because that's x, plus 8y plus 15 equals 0. So in the brackets, we've got 25 plus 3 5s is 15 times 2 is 30y. 3 3s is 9, so 9y squared plus y squared. 6 5s is minus 30. 6 3s is minus 18y, 8y, and 15. So we've got 10y squares, and then the 30y minus 18 is 12y, plus 8 is 20y, and then the numbers, 25 minus 30 is minus 5, plus 15 is 10, equals 0. 10 is a common factor, of course, out of all of this, so we could just take 10 out as a common factor to say y squared plus 2y plus 1. And then we need to check how many solutions has that got. Well, hopefully that's a complete square because we want a tangent, don't we? So that's 10, double brackets if you prefer, y and y, well, 1 and 1. 1 times 1 is 1, 1 plus 1 is 2, repeated root, and that means it's a tangent. to show us a tangent, so we've shown us a tangent, so we're done there. We could actually find the point. There is one other way to find out it's a tangent, by the way. If we go back to the equation 10 bracket y squared plus 2y plus 1, if I do this down here, we could check b squared minus 4ac. And if that is equal to 0, then it's a repeated root at that point, repeated, and therefore tangent. So that's the other way you could do this question. Check b squared minus 4ac at that point, and if you get 0, you can just say therefore it's a tangent. Now, if I asked you to find the point, you would say that y is minus 1 and then sub it in. So x is 5 minus 3, which is 2. So you get 2 minus 1 as a point. But it didn't ask you for that in this question. Or did it? No, it didn't. But let's just do it anyway. So the point of contact, we know that from the equation y plus 1 equals 0, that y equals minus 1, that we knew that x was equal to 5 plus 3y. So that's 5 plus 3 times minus 1, which is 2. So the point of contact is 2 minus 1xy. And we're done there. SQA High Maths 2016, Paper 1, Question 4. A and B are these points, and AB is the diameter of a circle. So there's the centre here. So I need the midpoint of A and B. The mid of A and B to get the centre is minus 7 plus 1 divided by 2, and 3 plus 5 divided by 2. That equals minus 7 plus 1 is minus 6, divided by 2 is minus 3. 3 plus 5 is 8, divided by 2 is 4. So we've got our centre of minus 3, 4. Now we can find our radius by finding the distance between C and B. Distance between C and B. So that's the distance formula. So that's the square root of minus 3 minus 1 squared. 4 minus 5 squared. So minus 3 minus 1 is 4. So that's 4 squared. 4 minus 5 is 1. So that's 1 squared. Or minus 1 squared. So that's 16 plus 1 is 17. Square root of 17. X minus a squared. So x plus 3 squared plus y minus b squared equals root 17 squared, which is 17. Maths 2016, Paper 2, Question 4 had this circle question. Circles C1 and C2 have these equations. And write down the centres and radius of the circles. So for part A, remember looking at the start of our exam paper, we are told quite a few things, but essentially minus 5 and 6 is the centre here. And for circle 2, well, we're going to have to do some work. So we call the number in front of x 2g. So if I say 2g equals minus 6, and the number in front of y we say is 2f, well, there's no y term, so that's 0. So g is minus 3 and f is 0. And the centre is defined as minus g minus f, so that is going to be 3 and 0. The radius of circle 1 is just the square root of 9, which is 3. And to get the radius of circle 2, remember it's the square root of f squared plus g squared, so 0 squared plus 3 squared minus c. Well, c is minus 16, so plus 16. So that's the square root of 9 plus 16, square root of 25, which is 5. Part B says, show that C1 and C2 do not intersect. Well, if we can work out the distance between the two centres and then work out the distance of the two radiuses together, if the two radiuses add up to less than the distance between the centres, then they don't intersect. So our distance between C1 and C2, well, that's just Pythagoras, so it's minus 5 minus 3 squared plus 6 minus nothing squared, distance formula. So that is the square root of minus 8 squared plus 6 squared. That's the square root of 64 plus 36. Square root of 100, which equals 10. So there's the distance between centres. Sum of the radius of the radii, well, that's just 3 plus 5, which equals 8. So since R1 plus R2 is less than the distance between the centres, the circles do not intersect. And we're done there. Basically, High Maths 2017, paper 2, question 10 on equation of a circle. It says show that points A, B, and C are collinear. And then it says they're drawn inside a bigger circle, and it tells you some radiuses. You have to determine the equation of the bigger circle with centre D. So let's tackle part A first, collinearity. So for part A, we've got A is minus 7 minus 2. We've got B is 2, 1. And we've got C is 17, 6. So to show that 3 points are collinear, you just need to examine the gradients between A and B and C. And if they are the same, they are parallel, but we've got a common point, so we're collinear. So the gradients between A and B, that is 1 minus minus 2 over 2 minus minus 7. That is 3 over 9, which is a third. So we've got a gradient to A and B. Now the gradient to B and C. Well, that is 6 minus 1 on the top and 17 minus 2 on the bottom. That's 5 over 15. So that's a third. So write a little statement. The gradient to A and B is equal to the gradient to B and C. So AB and BC are parallel. But B is a common point. So A, B, C are collinear. And we're done there. Okay, let's tackle part B. It says the centres A, B, and C have the radiuses root 10 to ARA and RC is RA plus RB. Determine the equation of the circle with centre D. So if the first one is root 10, the second one must be 2 root 10 because it's double the first one. And the third one is equal to the second one, the first one, which is root 10, plus the second one, which is 2 root 10. So that gives me 3 root 10 for my final radius. So we know, let's just annotate this circle. We know that A is minus 7 minus 2. Minus 7 minus 2. And we know that that is root 10. We know that B is 2, 1. And we know that this distance here is 2 root 10. That means it's the same on this side as well. And then C's point is 17, 6. But we know that C is now 3 root 10 from here to here. And for us to get the equation of a circle, we need two things. We need the radius of the circle and its centre. Well, do we know the radius? Well, let's just use a different colour. This distance here is also 3 root 10. So the radius from D all the way over to here is 3 root 10 plus 3 root 10, which is 6 root 10. So our radius, if I just write it at the side of the big circle, is 6 root 10. And now to get the centre D, well, let's have a look. That's 2 root 10, and that's 3 root 10. So if we take this distance here, which is 5 root 10, D, we could say, is 2/5 of the way along. 2 plus 3 is 5. So it's 2/5 of the way up. So let's just write that down. D is 2/5 of the way up BC. So then how do we get the centre? Well, it starts at 2 and it ends up at 17. So the difference between 2 and 17 is 15. 17 minus 2 equals 15. 2/5 of 15 is 6. So if we were to draw a kind of right angle triangle here, we know that along the bottom is 15, but it has to go along 6 first, and then along another 9, because it's 2/5 of the way along. So 6 plus 2 is 8. So to get our centre, we've got 8, and then going up the way. So we know that height is 5, so 2/5 of 5. That small distance in here then would be 2. So I'm starting at 1 and going up 2, so that makes it 3. So we then get the 0.83. Hopefully that makes sense. So we've now got our centre and we've now got our radius. So for part B, our centre was equal to 83 and our radius was equal to 6 root 10. So x minus a squared plus y minus b squared equals r squared, which is 6 root 10 all squared. Tidying that up, x minus a squared plus y minus 3 squared equals, well, this bit, 6 sixes is 36, root 10 squared is 10, it's 360. And we're done.
SQ High Maths 2018, Paper 2, Question 5. PQR is a triangle with 3, 4 and Q9 minus 2 as shown. Find the equation of the perpendicular bisector of PQ. This is a circle question, but the circle part comes later. So this is straight line to start with. So we need the equation of a perpendicular bisector. So that cuts this in half. So we need the midpoint. Well, that equals 3 plus 9 divided by 2 and 4 plus minus 2 divided by 2. That's 12 over 2, which is 6, and that's 2 over 2, which is 1. So we've got our midpoint, and then we need the gradient of PQ because this is perpendicular. So the gradient of P and Q is minus 2 take away 4, y2 minus y1 over 9 take away 3, x2 minus x1. That's minus 6 over 6, which is minus 1. So therefore, the gradient of L1 equals 1 since m1 times m2 equals minus 1. So now we can use y minus b equals mx minus a. Y minus 1 is equal to 1x minus 6. Or y minus 1 equals x take away 6. So y equals x minus 5. And we're done there. Let's move on to part B. Part B of this question says L2, the perpendicular bisector of PR, the equation of that is 3y plus x is 25. Calculate the coordinates of C, the intersection between L1 and L2. So we're solving simultaneous equations because it's find the point of intersection between two lines. So our first equation is given to us, 3y plus x equals 25. And we just worked out, remember, that y equals x minus 5. Was the other equation. So rearranging that so that everything's on the same side, you've got y minus x equals minus 5. Adding these together, you get 4y equals 20, so y equals 5. Subbing it into this equation here, we get 5 equals x minus 5, so x must be 10. The point of intersection is 10, 5. Part C of 2018, Paper 2, Question 5. This is where the circles come in. C is the centre of the circle which passes through the vertices of triangle P, Q and R. So C is our centre, which we've just worked out, remember, is 10, 5. So we can note that on our diagram. And it says determine the equation of this circle. Remember, the equation of a circle from the start of the exam paper is x minus a squared plus y minus b squared equals r squared. And a and b is our centre, and obviously r is the radius. So now we just need to work out the radius then. So we need the distance between the centre and one of the points. So any one would do, but we'll know p, we know q. So let's use p, let's work out this distance. I'll just draw it on for us. There's our radius there. So using our distance formula to get r equals the square root of x2 minus x1, so 10 minus 3 squared, plus y2 minus y1, 5 minus 4 squared. So that equals the square root of 7 squared plus 1 squared, which is the square root of 50. 7 7 is 49 plus 1 is 50. Now, we'd simplify that normally, but we're going to square it back up anyway because we need r squared. So now it's very simple. The equation of our circle is just x minus 10 squared plus y minus 5 squared equals 50, r squared. And we're done there. Next grade higher maths 2018, paper 2, question 12. Circle 1 has equation x minus 13 squared plus y plus 14 squared equals 100. And circle 2 has this equation. Write down the coordinates of the centre of circle C1. Well, that's nice and easy. C1 centre equals 13 minus 4. Part 2 says, the centre C1 lies on the circumference of C2, show that C is minus 455. So we've got our equation x squared plus y squared plus 14x minus 22y plus c equals 0. But we know that this centre lies on it. So if it lies on it, it means if I sub in 13 and minus 4 for x and y, that has to equal 0. Otherwise it wouldn't lie on it. So we can just do that. So we get 13 squared plus minus 4 squared plus 14 times 13 minus 22 times minus 4 plus c equals 0. Bit of maths to do, but this was a calculator paper, so you just get your calculator out and work it out. You get 169 plus 16 plus 182 plus 88 plus c equals 0. So then adding up all the numbers, you get 455 plus c equals 0, and therefore c is negative 455 as required. Okay, part B says, the line joining the centres of the circles intersects C1 at point P. Determine the ratio in which P divides the line joining the centres of the circle, and then find the coordinates of P. So the radius of C1, we already know, is equal to 10. And we can work out the radius of our second circle by using the formula at the start of the exam paper, but remember it is the square root of g squared plus f squared, so g is going to be 7 and f is minus 11 minus c, which is in this case 455, so plus c. So that gives us the square root of 625, just put it in a calculator, which is 25. So we've got our two radiuses. We know this radius here from C1 to P is 10. We know the radius from here all the way over to here is 25, so that must be 15, because 15 and 10 make 25. So the ratio is dividing, P is dividing the line, is simply 15 to 10, which we can simplify to 3 to 2. And we're done there. Part 2, hence or otherwise determine the coordinates of P. So the centre of our first circle is minus 7, 11. And then join another line. I'll draw a right angle triangle here. We know that the distance here must be 13 minus 7, which is 20. And we know that the distance up this side is 11 minus 4, which is 15. And P is 3/5 of the way along. So I just need to do 3/5 of 15. Nine and 3/5 of 20, which is 12. Minus 7 add 12 is 5. And for our y part, we're starting up at 11 and we're going down 9. 11 minus 9 is 2. So we get 5, 2. And we're done there. P is the centre of a third circle C3. C2 touches C3 internally. Determine the equation of C3. So it's best to probably draw a picture for this one. So there's our picture. We've got our original picture. And then we've got this new circle, and it says that C2 touches C3 internally. So it's touching it at one point inside the circle. And we have to determine the equation of C3. Remember, P is the centre of this big, massive circle. Okay? So our centre we already know is 5, 2. And we need to work out our radius. But we already know some information from what we've already worked out previously. We know that the radius of this big circle here is 25. And we know that the distance between here and here was 15, because it was 10 over here as well. 10 and 15 make 25. So if we know that this is 25, and from here to here is 15, then the radius of our new circle is 25 plus 15, which is equal to 40. So now we've got everything we need. We can just write down our equation of our circle, x minus 5 squared plus y minus 2 squared equals 40 squared. Working out 40 squared, you get x minus 5 squared plus y minus 2 squared equals 1600. And we're done. SQA Higher Maths, Paper 1, Question 3. Circle C1 has this equation and C2 has centre 4 minus 2. The radius of C2 is equal to the radius of C1. Find the equation of circle C2. So we have got our equation up here, and just remember, from our equation, x squared plus y squared minus 2x minus 2y minus 26 equals 0. You're given at the start of the exam paper the radius. The radius is quoted as equaling the square root of g squared plus f squared minus c. And your g and your f, well, this is called 2g and 2f. So 2g is minus 6 and 2f is minus 2. So my g is minus 3 and my f is minus 1. So my radius is equal to minus 3 squared plus minus 1 squared. Take away c, but it's a minus already, so plus 26. So that means that going down here, my radius is equal to the square root of 9 plus 1 plus 26. That's the square root of 36, which is equal to 6. So we've got our radius, and we know the circle centre is 4 minus 2. So we know the equation of C2 must equal x minus 4 squared plus y plus 2 squared equals 36. And we're done there. SQA Higher Maths 2019, Paper 2, Question 15. A circle has centre 8, 12. P 513 lies on the circle as shown on the outside. Find the equation of the tangent at P. Now, if we want to find the equation of the tangent, if it's about circles, a tangent meets a radius at right angles. So we can find the gradient of the radius, and then m1 times m2 equals minus 1. So we'll just do that. Let me just draw that picture in so it's really clear. That's a right angle. So the gradient of C to P, or P to C, is 13 take away 12, over 5 take away 8. That's 1 over minus 3, or minus a third. So the gradient of our perpendicular equals 3, since m1 times m2 equals minus 1. And we've got our point. Our point is 513. So it's just now straight line work. Y minus b equals mx minus a. So y minus 13 equals 3x minus 5. Y minus 13 is 3x minus 15. So y equals 3x minus 2. And we're done there. Part B says the tangent of P meets the y-axis at point T. State the coordinates of T. Part B, aye. Remember, the equation of our tangent is 3x minus 2. So it meets the y-axis when x is 0, in other words, minus 2. So the point is just equal minus 2. And we're done there. So part B2 says find the equation of a circle that passes through the points C, P and T. So if we've got the picture of it here again, we've got C, P and T, and we're saying that there's some circle that goes through all three of these points, a bigger circle. Now, if I've not drawn an accurate sketch of this, but we know that this is a right angle it's meant to be at P. Now that only happens in a circle when we make a triangle, and that would be the diameter. So we now know essentially that CT is the diameter, and therefore we can work out the midpoint of C and T. So the midpoint of C to T, well, we've got 8, and then that is, remember, T is 0 minus 2, so it's 8 plus 0 divided by 2, and it is 12 minus 2 divided by 2, so that's 8 over 2 is 4, and we've got 10 over 2, which is 5. So we know our midpoint now is 4, 5. Now we need to know the radius, so we can do the distance between C and T. Remember, T is 0 minus 2. So the distance from C to T equals the square root of 4 minus 0 squared is 4 squared, and then 5 minus minus 2 squared is 7 squared. So it's 4 squared is 16 plus 49. That is the square root of 65. And therefore the equation of a circle that goes through these points is simply x minus 4 squared plus y minus 5 squared equals 65, root 65 squared. And we're done there. Bye.
SQA Higher Maths 2021, paper 1, question 15 on equation of a circle. A, B, C, and D is a square containing 4 congruent circles, and our circles are all the same. A is the point 2, 1, let's just note that. And D is the point 10, 1. And it asks us to find the equation of the circle with centre P. Well, remember, for the equation of a circle, we need 2 things: the centre and the radius. So let's work on the centre first, shall we? As a square, it says, so I can work out half the way along here. So let's just write this down. We can find the middle of there, the middle of A and D, midpoint, 10 plus 2 divided by 2, and 1 plus 1 divided by 2. So that gives me 12 divided by 2 is 6, and 2 divided by 2 is 1. So we know at this point here is 6, 1. The middle of 6, 1 and 10, 1. It's clearly going to be 1 on the end because it's on the same straight line. 6 plus 10 is 16 divided by 2 is 8. So we know at this point is along 8 and at 1. And we now need to decide how far up we go. So if we just work out the diameter of one of the circles, it goes from 2 to 6. That's 4 units. So we know it goes up 4 units there. So I can just kind of draw that in. 4 units. And then another radius is 2 units. So it goes up 6 units. From 1, no. 1 plus 6 is 7. So we know our centre is 8, 7. And what about our radius? Well, we've already drawn it in 2. And our radius is 2. So the equation of the circle is nice and easy now. It's x minus 8 squared plus y minus 7 squared equals 4. 2 times 2 is 4.
Line y equals 3x plus 7 intersects the circle x squared plus y squared minus 4x minus 6y minus 7 at the points P and Q. Find the coordinates of P and Q. So I need to substitute y equals 3x plus 7 into it because they intersect. So part A, try to find the points of intersection. So I'm going to sub y equals 3x plus 7 into the circle. So to see a y, I'm going to write 3x plus 7. So I've got x squared plus 3x plus 7 all squared minus 4x minus 6. 3x plus 7 minus 7 must equal 0. So that gives me x squared plus 9x squared. 3 7s is 21, double that is 42x, 7 7s is 49, minus 4x, minus 18x, minus 42, minus 7 equals 0. So we've got in total 10x squareds. We've got 42 minus 18 minus 4, which is plus 20x. And then we've got 49 minus 42 minus 7, that's 0. So that equals 0. So we can factorise that nice and easy. 10x is a common factor, obviously. X plus 2 equals 0. So that gives me 2 solutions. X equals 0 or x equals minus 2. To get our y's, we can just substitute them in. So at x equals 0, y equals 3 times 0 plus 7. Which equals 7. So the first point we get is 0, 7. And at x equals minus 2, we get y equals 3 times minus 2 plus 7 minus 6 plus 7. That's 1. So our second point is minus 2, 1. So there's our P and there's our Q. Well, part B says PQ is the tangent to a second smaller circle. It's concentric with the first. Determine the equation of the smaller circle. So let's put some information onto this circle. First of all, the centre of this circle. Well, that's just going to be 2, 3, half and half. Switch the signs. We already know the coordinates of point P and Q. 0, 7 and minus 2, 1. Now if I draw this in, if I draw a radius going straight out to the bigger circle, well, it meets this chord at right angles and cuts it in half. So I can find this midpoint. So the mid of P and Q, well, that's just 0 plus minus 2 over 2 and 7 plus 1 over 2. Minus 2 over 2 is minus 1. 8 over 2 is 4. So our midpoint is minus 1, 4. So now we have the midpoint and we have the centre. We can work out the radius using the distance formula. We have got the square root of x2 minus x1 squared, so 2 minus minus 1 squared, plus y2 minus y1 squared. So that's 3 minus 4 squared. So that gives me the square root of 2 minus minus 1 is 3 squared, which is 9, plus minus 1 squared, which is 1, giving you a radius of the square root of 10. So our equation is just x minus 2 squared plus y minus 3 squared equals root 10 squared, which is 10. Okay, SQA Higher Maths 2015, paper 1, question 11. T minus 2 minus 5 lies on the circumference of the circle with this equation. Find the equation of the tangent to the circle passing through T. So let's work out the equation of the tangent. If we draw a little picture, just to give us an idea of what's happening, let's say that T is here. And we'll call that minus 2, minus 5. And this is not an accurate picture. Then we've got our centre of our circle where we can work out our centre. It's minus 8, minus 2. And we have to find the equation of a tangent passing through T. So a tangent makes a radius at right angles. From National 5. So if we work out the gradient between the centre and T, then m1 times m2 equals minus 1. So the gradient, I'll just call this the centre, C, between C and T, equals minus 5 minus minus 2 over minus 2 minus minus 8. That's minus 5 add 2 is minus 3. Minus 2 add 8 is 6. So that's minus a half. So therefore, the gradient of our perpendicular equals 2, since m1 times m2 equals minus 1. So we've got our gradient of 2, and then we can use our point. So y minus b equals mx minus a as usual. The point obviously we're using is t. So it's y plus 5 minus minus 5 equals 2x plus 2. Multiplying that out, we get y plus 5 is 2x plus 4. So y equals 2x minus 1 is the equation of our tangent. Part B says the tangent is also a tangent to a parabola with equation y equals minus 2x squared plus px plus 1 minus p. Determine the value of p. So we've got y equals 2x minus 1, and then for part B, we've also got y equals minus 2x squared plus px plus 1 minus p. And since this is a tangent to this, then these are equal to each other. We can solve them simultaneously. So all we need to do is say that 2x minus 1 equals minus 2x squared plus px plus 1 minus p. So that's a quadratic to solve. So moving everything over to the same side, or just move everything over to the right, we get 2x squared plus 2x minus px, then minus 1, then minus 1 again, and then plus p, and that equals 0. Tidying that up, squared, and then we want to have x as a thing, so that is plus 2 minus p times x, and then we've got as a constant term minus 2 plus p equals 0. Now if it's a tangent, b squared minus 4ac equals 0, because it only has one solution. So that means we can say, remember, that would be our A, this would be our B, and this whole thing here would be our C. So we can say that we've got 2 minus p all squared minus 4 times 2 times minus 2 plus p equals 0. Solving that, multiplying out the bracket, we get 2 2's is 4 minus 4p plus p squared, and then we've got minus 8 times minus 2 is plus 16, and then we've got minus 8 times p, so minus 8p equals 0. Continuing on to solve this then, we've got p squared minus 12p plus 20 equals 0. So another quadratic to solve, but this one should be factorizable hopefully. Double brackets, we've got p and p. 10 and 2 make 12 when you add them, so it's 10 and 2 minus 10 minus 2. So p equals 2 or p equals 10. But then if we go back to the original question, it says p is greater than 3. So with disregarding this one, p equals 10 as our final answer. SQA Higher Maths 2017 Paper 1 Question 2. This point P lies on this circle. Find the equation of a tangent at P. So I've already drawn a picture. P could be round about here, minus 2, 1. And a tangent makes a radius at right angles. So if I knew the centre, then I could find the gradient of the centre and use perpendicular gradients. And then y minus b equals mx minus a. Now, from the start of the exam paper, you're given this formula. X squared plus y squared plus 2gx plus 2fx plus c equals 0. And then the centre, that's the big C here, is minus g minus f. And the radius is g squared plus f squared minus c, c being in here. So 2g is the number in front of x, so 2g is minus 8. And 2f is the number in front of y, which is minus 6. So g is minus 4 and f is minus 3. So our centre is 4, 3. Let's call that our centre. Now we can do the gradient between c and p. So that's 3 minus 1 over 4 minus minus 2. That is 2 over 6, which is 1/3. So the gradient of our perpendicular must be minus 3, since m1 times m2 equals minus 1. And the point we've got is minus 2, 1. So y minus b equals mx minus a, so plus 2. So y minus 1 minus 3x minus 6. So y equals minus 3x minus 5. And that's the equation of our tangent. SQA Higher Maths 2018 Paper 1 Question 4. The point K lies on the circle with this equation. Find the equation of the tangent to the circle at K. Tangent meets a radius at right angles. So we need to find the centre of our circle. So we've got it in expanded form. So from the start of the exam paper, we are told that x squared plus y squared plus 2gx plus 2fx plus c equals 0 is the equation of a circle where the centre is equal to minus g minus f and the radius is equal to the square root of g squared plus f squared minus c. So looking up at our equation, the number in front of f, 2g is minus 12, and the number in front of y, 2f is minus 6. So that gives me g is minus 12 divided by 2, minus 6, and it gives me f is minus 6 divided by 2, minus 3. So our centre is just simply 6, 3. Once we've got our centre, we can find the gradient between our centre. Let's just call our centre C. So the gradient between C and K is minus 5 take away 3 on the top and 8 take away 6 on the bottom. Minus 5 take away 3 is minus 8 over 2, which is minus 4. So the gradient of our perpendicular equals a quarter, since m1 times m2 equals minus 1. So our point is 8 minus 5 for k. So we can use y minus b, y plus 5 equals m x minus a, which is 8. Times it through by 4, we get 4 times y plus 5 equals x minus 8. So 4y plus 20 is x minus 8, or to leave it in a nice way, 4y minus x equals minus 28 would be a fine answer. If you prefer y equals, you can divide through by 4 to get y equals a quarter of x, and then minus 28 divided by 4 is minus 7 if you prefer. The Higher Maths 2019 Paper 2 question 15. A circle has centre 8, 12. P 513 lies on the circle as shown on the outside. Find the equation of the tangent at P. Now, if we want to find the equation of the tangent, if it's about circles, a tangent meets a radius at right angles. So we can find the gradient of the radius, and then m1 times m2 equals minus 1. So we'll just do that. Let me just draw that picture in so it's really clear. That's a right angle. So the gradient of C to P, or P to C, is 13 take away 12 over 5 take away 8. That's 1 over minus 3, or minus a third. So the gradient of our perpendicular equals 3, since m1 times m2 equals minus 1. And we've got our point. Our point is 513. So it's just now straight line work. Y minus b equals mx minus a. So y minus 13 equals 3x minus 5. Y minus 13 is 3x minus 15. So y equals 3x minus 2. And we're done there. Part B says the tangent of P meets the y-axis at point T. State the coordinates of T. Part B, aye. Remember, the equation of our tangent is 3x minus 2. So it meets the y-axis when x is 0, in other words, minus 2. So the point is just equal minus 2. And we're done there. So part B2 says find the equation of a circle that passes through the points C, P and T. So if we've got the picture of it here again, we've got C, P and T, and we're saying that there's some circle that goes through all three of these points, a bigger circle. Now, if I've not drawn an accurate sketch of this, but we know that this is a right angle it's meant to be at P. Now that only happens in a circle when we make a triangle, and that would be the diameter. So we now know essentially that CT is the diameter, and therefore we can work out the midpoint of C and T. So the midpoint of C to T, well, we've got 8, and then that is, remember, T is 0 minus 2, so it's 8 plus 0 divided by 2, and it is 12 minus 2 divided by 2, so that's 8 over 2 is 4, and we've got 10 over 2, which is 5. So we know our midpoint now is 4, 5. Now we need to know the radius, so we can do the distance between C and T. Remember, T is 0 minus 2. So the distance from C to T equals the square root of 4 minus 0 squared is 4 squared, and then 5 minus minus 2 squared is 7 squared. So it's 4 squared is 16 plus 49 plus 7 squared is 120. So 120 plus 49 is 180. So 180 plus 120 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 that is the square root of 65. And therefore the equation of a circle that goes through these points is simply x minus 4 squared plus y minus 5 squared equals 65, root 65 squared. And we're done there. SQA Higher Maths 2021 Paper 2 Question 14. The point A35 lies on the circle with this equation. Find the equation of a tangent at A. So let's find the centre first of all. There's our centre there, let's call it C. And remember from the start of the exam paper, it is minus G minus F, where that is 2G and that is 2F. So I'll just divide that by 2 to get 5 and change the sign. So it's minus 5 becomes 5, and 2 goes to 1, so that's minus 1. So we get 5 minus 1 as our centre. So now our gradient between C and A is simply 5 minus minus 1 on the top and 3 minus 5 on the bottom. Well, that's 6 over minus 2, which is minus 3. So therefore, the gradient of the tangent is equal to 1/3 as m1 times m2 equals minus 1, because they're perpendicular, remember. Tangent means radius at right angles. So now we use y minus b equals mx minus a. So our point is 3, 5. That's our a and our b. And our gradient is equal to 1/3. So y minus 5 equals 1/3 x minus 3. So y minus 5 equals 1/3 of x minus 1, or y equals 1/3 of x minus 1 plus 5 is 4. So 1/3 of x plus 4, and we're done there. SQA Higher Maths 2016 Paper 1 Question 8, the intersection of lines and circles this time. Show that the line with equation y equals 3x minus 5 is a tangent to the circle with this equation, and find the coordinates of the point of contact. So if it is a tangent, it means this y is equal to the y in here. So I can substitute this into this equation. So I've got x squared plus 3x minus 5 squared plus 2x minus 4 times 3x minus 5 equals 0. So multiplying out our brackets, we get x squared plus 3 3s are 9, so 9x squared. 3 5s is 15 times 2 is 30, so minus 30x plus 25 plus 2x. 4 3s is 12, so minus 12x. 4 5s is 20, so plus 20, then minus 5 equals 0. So you're going to get a quadratic. So we've got x squared plus 9x squared is 10x squared. Minus 30x plus 2x is minus 28x. Minus 12x is minus 40x. And then we've got our number part, 25 plus 20 is 45 minus 5 is 40. And we know that that equals 0. So we can solve that by taking 10 out as a common factor to get x squared minus 4x plus 4 equals 0. And then let's solve it. Now we're looking if it's a tangent for only one solution, because it only touches it at one point. So this should be equal roots. So let's check x and x. 2 2s is 4, so minus 2 equals 0. So we can say that it's got equal roots. So only one point of contact. Therefore, the line is a tangent to the circle. Find the coordinates of the point of contact. Well, we've already got this equation equal to 0, so that implies that x equals 2. And then subbing that back in to get our y, well, we might as well just use our original equation, y equals 3x minus 5. So we've got y equals 3 times 2 minus 5. 6 minus 5 is 1, so we've got 1 and 2. So our point of contact is 2, 1. And we're done there. The intersection of lines and circles again. The line 3x intersects the circle with equation x minus 2 squared plus y minus 1 squared equals 25. find the coordinates of the point of intersection. So if they intersect, it means we're solving them simultaneously to see these points. So y equals 3x is our first equation. And when we'll write down our circle equation, x minus 2 squared plus y minus 1 squared equals 25. So to solve these simultaneously, we use substitution. We know that y is 3x, so we'll replace the y with 3x in this equation. So we've got x minus 2 squared plus 3x minus 1 squared equals 25. Multiplying out our brackets to get a quadratic then, we've got x squared minus 4x plus 4 for the first bracket, and then we've got 3 3s is 9x squared, 3 1s is 3, double that is 6, so minus 6x plus 1. And then I'll just take away 25 and make it equal to 0 because I'm going to get a quadratic. If you're struggling with multiplying out these brackets, you can just take your time and multiply them out any way you want. So we've got x squared and 9x squared is 10x squared minus 10x. 4 plus 1 is 5 minus 25 is negative 20 equals 0. 10 is a common factor. X squared minus x minus 2. So 10, hopefully it's factorizable. 2 and 1. We want to get minus 1, so it's minus 2 plus 1 is minus 1. Minus 2 times 1 is minus 2. So x equals minus 1 or x equals 2. We've got our x point, now we need to get our y point. So when y equals 3x, at x equal to minus 1, y equals minus 3. The point is minus 1 minus 3. And for y equal to 3x, when x equals 2, y equals 6. So our point is 2, 6. There's our 2 points of contact. And we're done there. SQA High Maths 2021, Paper 2, Question 15. The line y equals 4 minus 2x intersects this circle at the points P and Q. Find the coordinates of the points of intersection. So this is substitution for simultaneous equations. So I'll just substitute y into my equation of the circle. So we've got x squared plus y squared, so that's 4 minus 2x squared, minus 10x minus 8 times 4 minus 2x. And then we've got plus 1, and that equals 0. And we just solve to find x, then sub in to find y. So x squared plus, double brackets, 4 4s is 16. 4 2s is 8, so double that to 16 as well, so minus 16x. And then 2 2s is 4, 4x squared. Minus 10x. Minus 4 8s is 32. And then minus times a minus is a plus, so plus 16x. And then we've got plus 1 sitting on the end equals 0. Collecting all the terms together, so the x squareds, there's 5x squareds. And then the x's, minus 16 minus 10 plus 16 is minus 10x. And then the number parts, we've got 16 minus 32 is minus 16 plus 1 is minus 15. And that equals 0. So we're solving a quadratic. Take 5 out as a common factor to get x squared minus 2x minus 3 equals 0. And then hope it factorizes, otherwise it's a quadratic formula. Well, it does factorize. We've got x and x, 3 and 1, minus 3 plus 1 is minus 2. So that gives me that x plus 1 equals 0, or x minus 3 equals 0. So that means that x is equal to minus 1, or x is equal to 3. There's our two x's. Now we just use the original y equation. Y equals 4 minus 2x. X equals minus 1. Y equals 4 minus 2 times minus 1. So that is 4. 2 times 1 is 2, plus 2 is 6. So the first coordinate is minus 1, 6. And then the next one, when x equals 3, y is 4 minus 2x. So 2 times 3. 2 3s is 6, 4 minus 6 is minus 2. So our other point is 3 minus 2. There's our two final answers, and we're done there. The line y equals 3x plus 7 intersects the circle x squared plus y squared minus 4x minus 6y minus 7 at the points P and Q. Find the coordinates of P and Q. So I need to substitute y equals 3x plus 7 into it because they intersect. So part A, try to find the points of intersection. going to sub y equals 3x plus 7 into the circle. So to answer y, I'm going to write 3x plus 7. So I've got x squared plus 3x plus 7 all squared minus 4x minus 6. 3x plus 7 minus 7 must equal 0. So that gives me x squared plus 9x squared. 3 sevens is 21, double that is 42x. 7 sevens is 49. Minus 4x minus 18x minus 42 minus 7 equals 0. So we've got in total 10x squareds. We've got 42 minus 18 minus 4, which is plus 20x. And then we've got 49 minus 42 minus 7, that's 0. So that equals 0. So we can factorise that nice and easy. 10x is a common factor, obviously. X plus 2 equals 0. So that gives me two solutions. X equals 0 or x equals minus 2. To get our y's, we can just substitute them in. So at x equals 0, y equals 3 times 0 plus 7, which equals 7. So the first point we get is 0, 7. And at x equals minus 2, we get y equals 3 times minus 2 plus 7 minus 6 plus 7. That's 1. So our second point is minus 2, 1. So there's our P and there's our Q. Well, part B says PQ is the tangent to a second smaller circle, is concentric with the first, determine the equation of the smaller circle. So let's put some information onto this circle. First of all, the centre of this circle, well, that's just going to be 2, 3, half and half, switch the signs. We already know the coordinates of point P and Q, 0, 7 and minus 2, 1. Now if I draw this in, if I draw a radius going straight out to the bigger circle, well, it meets this chord at right angles and cuts it in half. So I can find this midpoint. So the mid of P and Q, well, that's just 0 plus minus 2 over 2 and 7 plus 1 over 2. Minus 2 over 2 is minus 1. 8 over 2 is 4. So our midpoint is minus 1, 4. So now we have the midpoint and we have the centre. We can work out the radius using the distance formula. We have got the square root of x2 minus x1 squared, so 2 minus minus 1 squared, plus y2 minus y1 squared, so that's 3 minus 4 squared, so that gives me the square root of 2 minus minus 1 is 3 squared, which is 9, plus minus 1 squared, which is 1, giving you a radius of the square root of 10. So our equation is as x minus 2 squared plus y minus 3 squared equals root 10 squared, which is 10. Yeah, Maths 2023, paper 2, question 15, the last one. The line x plus 3y equals 17 is a tangent to a circle at the point 2, 5. And it also says the centre of the circle lies on the y-axis. So if we imagine this is a y-axis here, somewhere that centre is on that y-axis. So now it asks us to find the coordinates of the centre of the circle. This is quite a tricky one, this one, but let's just start dealing with it. Where's our centre here? We know that the radius meets the tangent at right angles. So if I knew the gradient here, I would automatically know this. So let's start on that point. We've got x plus 3y equals 17. 3y then equals minus x plus 17. Y equals minus a third of x plus 17 over 3. The gradient of that is minus a third, and therefore the gradient of the perpendicular is equal to 3 because m1 times m2 equals minus 1.
we also know that the centre of the circle lies on the y-axis. So if it lies on the y-axis, it goes along 0. So if I draw an x-axis in, we don't know where this x-axis is, so I'm not going to put it there. That's like our x-axis. It goes along 0 and up some number, call it c. But we know our gradient is 3, and we've got 2 points, so we can use the gradient formula and work out our c. So let's just do that. We've got 0c, and we've got 2, 5. So y2 minus y1, 5 minus c equals 2 over 2 minus 0 equals our gradient of 3. So we've got 5 minus c over 2 equals 3. 5 minus c equals 6. So I'll just take the 5 over minus c equals 6 minus 5. 6 plus 5 minus c equals 6 minus 5, which is 1. So c equals minus 1. So the centre of the circle is simply 0 minus 1. And we're done there.
Next grade higher maths 2015 paper 2 question 5. Circle C1 has equation x squared plus y squared plus 6x plus 10y plus 9 equals 0. And the centre of C2 is 9, 11. There's C2 there, so let's just call that 9, 11. And the touch, determine the radius of C2. Well, we'll just find out all we can, so let's see if we can find the centre of C1. We have got this equation here, and we know from the start of the exam paper that minus g minus f is a circle's centre. So to get minus g minus f, you just divide these by 2 and change the sign. So that becomes 3, 5. So that's minus 3 minus 5. So we can write that for that centre. What else do we know? Well, we also know the radius of C1. So if we knew the radius of C1 and maybe this whole distance, we could find the radius of C2. So let's do the whole distance first. So the distance between, let's call it C1 and C2. Distance formula is Pythagoras, so it's 9 minus 3 squared, the x's, plus 11 minus 5 squared. That equals the square root of 12 squared plus 16 squared. That is 400, which gives me 20. So we now know the distance all the way up here is 20. So let's now find the radius of circle C1. So again, start of the exam paper, radius is equal to the square root of g squared plus f squared minus c. So we know g and f are just our centres. So therefore we can say the radius of C1 or R1 is equal to the square root of 3 squared is g plus 5 squared is f minus c, which is minus 9. So that is 9 plus 25 minus 9 is 25. So therefore the radius R1 is equal to 5 units. So we now know, I'll just use a different colour, that from here to here is 5. And therefore from there to there must be 15. Therefore R2 equals 20 minus 5, which is 15. And we're done there. So it now says, for part B, a third circle is C3 is drawn such that C1 and C2 touch internally with C3, and the centres of C1, C2, C3 are collinear, so they line up in a straight line. And we have to determine the equation of C3. A little sketch to illustrate this will be handy for you. This point here is minus 3 minus 5, and we know that the other point is 9, 11 here. And we want to know where the centre of the big circle is, and therefore what its radius is. So we're kind of looking at this line going through. Now we know the radius as well of C1 is 5, so we know that this line here is 10. We're going to go 5 on this side and 5 on that side. And we also know the radius of our big circle now is 15, or our big one in the middle. So that's 15 and 15. So we can use ratio to see how much the line divides the circles. So you should be able to see that a centre of the big circle, if I just kind of do it there, is kind of roughly there. So if I kind of mark that point, that's the centre of like C3 roughly there. And we need to know where that is. So let's see how we divide this up. So if I kind of just draw a right angle triangle here, there it is. You can see that this distance is going from -3 all the way over to 9. So that's 12. And we can see that this distance is from -5 all the way up to 11. So that's 16. So the diameter of a big circle is 30 plus 10, which is 40. So the radius of a big circle is 20. So we know that from the big circle from here to there is 20. Or I'll just write that. The radius of 3 is 20 at the side. So we know that this bit here is like 5. So this bit in here must be 10 because it goes 10 plus another 10 makes 20. So that must be 10 in there. So if we think about moving from here to here, we move 15 units. And then from here to here, we move 5 units. So the ratio is 3 to 1. So if we divide 12 by 4, we get this line must be 3. And if we divide 16 by 4, this line up here must be 4. That must be a 3, 4, 5 triangle there. So then we can get the centre just by working backwards from 9, 11. It's taking 9, 11. Our centre, which I'll just do in a different colour. 9 minus 3 is 6. And 11 minus 4, 7. So we get our centre of our circle finally is 6, 7. So we've got our centre and we've got our radius. So the equation is x minus 6 squared plus y minus 7 squared equals 20 squared. And we're done there. Or we can say x minus 6 squared plus y minus 7 squared equals 400.
Higher Maths 2023, Paper 2, Question 11. Circle C1 has this equation and C2 has that equation. Find the distance between the centres for part A. So again, looking at the start of our exam paper, it tells us that it's x minus a plus x minus b, y minus b squared equals 37. So the centre of C1 is just 4, opposite of minus 4, and minus 2, the opposite of 2. For the centre of C2, so if we examine C2 first of all, it is minus g minus f, where that is 2g and 2f. So we know that 2g equals 2 and 2f equals minus 6. So g is equal to 1 and f is equal to minus 3. So our centre of C2 is just minus g minus f minus 1, 3. So now we want the distance between them. So it's the distance formula argued with Pythagoras. The difference between the x squared plus the difference between the y squared. So the distance is just going to equal the square root of, we've got 4 minus minus 1 squared plus minus 2 minus 3 squared. That is equal to 4 minus minus 1 is 5, so 5 squared. Minus 2 minus 3 is also 5, so 5 squared. Or minus 5 squared if you prefer. 25 plus 25 is root 50. We can simplify that as a third if we want, or just place root 50 in our calculator if you don't want to mess about with thirds. That is a calculator paper after all. But root 25, root 2, root 25 is 5, so we can leave it as 5 root 2, or put it in our calculator. Part B says, hence show that C1 and C2 intersect at 2 distinct points. So we already know that the distance between the centres is 5 root 2. Now, if you had put that in a calculator, you would get an answer of 7.07. So I'm just going to note that for now. And then for part B, to work out whether they intersect at 1 point, 2 points, or no points, you need to examine the distance between the radiuses. So I'm going to need my radiuses C1 and C2. So the radius of C1 is equal to the square root of 37 because it's equals r squared. The radius of C2 is given by the square root of g plus f minus c. G squared plus f squared minus c squared minus c. So the radius of C2 is equal to the square root of, remember our g and f were 1 and minus 3. So it's just 1 squared plus minus 3 squared. Take away c, which is the number on the end, minus minus 7. So it's minus minus 7. So that is 1 times 1 is 1. 3 3s are 9. Minus 7 is plus 7. Plus 7. And 9 plus 1 is 10. Plus 7 is root 17. So the distance between the centres is the radiuses is so the radius is C2 is just root 17. And we've got root 37 for C1. So we might as well turn them into numbers and add them together, because if you add up the radiuses and it's bigger than the distance between the centres, it means it touches at 2 distinct points. So illustrating that point, let's say we had 2 circles. You've got 2 options. We could touch like this, or we could touch like that, or I suppose we could be that. There's other options with it internal each other, but that's your main ones. If you look at the centres here, it's easy to see from the ones that don't touch. If that distance there, the distance between the centres, is bigger, that is obviously bigger than the radiuses, so we don't touch. That distance there is clearly the same as the radiuses added together, so we touch on the 1 point. That distance there then must be shorter than the radiuses added together. Or in other words, the radius added together is bigger than the distance between the centres. They touch at 2 distinct points. So all we need to do is check what R1 plus R2 is. So R1 plus R2 equals root 37 plus root 17. So you get your calculator out, and that gives you 10.02. So since 10.02 is greater than 7.07, the distance between the centres, the circles touch at 2 distinct points. And we're done there.
Okay, some unusual circle questions. 2015 paper 1 question 14. A circle with this equation meets the coordinate axis exactly 3 points. What is the value of k? So drawing a quick sketch of this, we've got 2g is minus 12 and 2f is minus 10. So g is equal to minus 6 and f is equal to minus 5. So our centre is equal to 6, 5. So along 6 up 5 somewhere is the centre of our circle. Touches the coordinate axes at exactly 3 points. So it could, if this is the centre here, it could touch here, but then it would have to touch at this point to come back up here. So if we draw a picture of that, we get something like this. That would be one option. And this is just a wee quick sketch to get an idea of what's happening. But also, we could have the y-axis be a tangent. So we could also alternatively have something like this is a tangent, but then it dips under. And this is a 0.65. So that's our 2 options for this question. So we'll just look at option 1 and option 2. So let's look at option 1. So let's look at the radius. We know it has 0, 0. So the radius of this is just going to be 6 minus 0 squared, which is 6 squared, plus 5 minus 0 squared, which is 5 squared. 6 sixes is 36, plus 25. That's just the square root of 61. So in option 1, we just get the square root of 61. So we know our radius is the square root of 61. But from the equation, g squared plus f squared minus c equals the radius. So we know that g and f is 6 and 5, but we've got c as k. So from the equation, we also get our radius is equal to the square root of 6 squared plus 5 squared minus k, because c is k. That is the square root of 61 minus k, and therefore k must be 0. That should be pretty obvious. So for option 1, k is 0. Now let's look at option 2. So in option 2, from the equation, our radius will still equal the square root of 61 minus k. But if we've got some points here, so this is along 6, so we know that that's the point 0.6. Our radius is 6 in other words, so we know that the square root of 61 minus k must equal 6. Square on both sides, we get 61 minus k equals 36. So that means that k equals 61 minus 36, which is 25. So there's our two options for k. K could be 25 or k could be 0, depending on what exactly is happening in this question. Okay, unusual circle questions. SQA Higher Maths 2019 Paper 1 question 16 had this one. P is the point with coordinates 4k and C is the centre of the circle with this equation. Show the distance between P and C is given by square root of k squared plus 4k plus 13. So part A, we've got our points 4 and k, and the centre of our circle is equal to, well, let's have a look. We've got 1 minus 2. So we can work out the distance between them. That is going to be the square root of the difference in the x's, 4 minus 1 squared, plus the difference in the y's, k minus 2 squared. Tidying that up, we get the square root of 3 squared plus k plus 2 squared. That equals the square root of 9 plus k squared plus 4k plus 4, which equals the square root of k squared plus 4k plus 13 as required. Part B says, hence otherwise find the range of values of k such that p lies outside the circle. So let's draw a little picture for this. We've got a circle and the centre of that circle is 1 minus 2. And we can look to see what the radius is. We know the radius is 5, the square root of 25. So that distance is 5, that's our radius. So if P is outside the circle, then clearly the distance between the centre and P must be bigger than 5. It has to be over 5. So we can then just say that the square root of k squared plus 4k plus 13 is greater than 5. And we can go from there. That's because our radius, remember, is 5. So, quadratic inequality, square both sides, k squared plus 4k plus 13 is greater than 25. Taking the 25 over, we get k squared plus 4k minus 12 is greater than 0. And this is a quadratic inequality, so we examine the roots. So looking at our roots, we've got k squared plus 4k minus 12 is equal to 0. Double brackets, we get k and k, 6 and 2, plus 6 minus 2 is 4. So our roots happen at k equal to 2, or k equals minus 6. Drawing a quick sketch then of that graph, we get 2's over here somewhere, minus 6 over here. It's a positive k squared, so it is a happy face. We don't need the turning point or anything because we're just looking to see when is this bigger than 0. Well, it's bigger than 0 above the x-axis, so it's over this side, it's always bigger than 0, and over this side, it's always bigger than 0 as well. So our final answer is k is less than minus 6, or k is bigger than 2. And we're done there.